The concept of this deep replacement, okay, whereby to improve the weak or problematic area, okay, and replace it with a more stronger and stiff material, okay, to become more stable soil. Okay. So usually they replace what we call as the weak soil, okay, with a compacted granular fill. Okay. So um, later on, okay, the weak soil, okay, become like a composite soil, okay, where it consists of several improvement area ratio, okay, by uh, install or replace the weak area with compacted granular fill, okay, uh, like installing the pile. Okay. So they use, for example, a gravel or crushed stone. Okay. So that is why we heard about stone column, okay, or sand column, okay, where the material is a little bit strong and stiff compared to the existing structure or sorry, existing area. Okay, it can be it can improve the bearing capacity. Okay, and also can reduce what we call as the settlement issue. Okay. It also can be a part of drainage systems. Okay. So, for example, okay, when we use the sand, okay, we heard about the prefabricated uh, vertical drains. Okay? So it can be the use of a sand, okay, they call as a weak drain, okay, whereby it made from a sand. Okay? So it also can help to accelerate the consolidation process, okay, by using these drain systems. Okay, so beside the use of the sand column or stone column, so another part that can be considered as what we call as a deep replacement, okay, is the use of the deep soil mixing. Okay? So when I did my PhD, okay, uh, I study on the behavior of the deep mixing methods. Okay? So, uh, however, I did my study using small scale physical modeling. Okay? If I'm not mistaken, I have shared before with you the layout or the or the system that I use, okay, to study for the deep mixing methods. Okay? So the idea of the deep mixing methods in actual, okay, so they mix the soil, existing soil, with a stabilizer or a binding agent. Okay? So they have a special nozzle and a special auger with a nozzle at the bottom. So during the mix or during the uh, do the drilling or augering, so they will mix the stabilizer with the existing soil. Okay, for example, like a marine clay. So then this stabilizer later on we make or improve the strength and the stability of the existing soil, especially on the marine clay or any cohesive material. So usually they use a stabilizer agent like cement or lime, okay, because it is easy and it is a commercial product. Okay, so now there are a lot of stabilizer which is called as a non-traditional. Okay, so means that beside the use of cement or lime, so they use any other type of stabilizer usually obtained from the waste product from the industry. For example, from the palm oil industry, the waste product from the palm oil, so they use as a part of the stabilizer. Okay, so that is a deep replacement technique. Okay, then what you may learn, okay, for this uh, deep replacement, okay, understand the basic concept of deep replacement technology and its applications. Okay. Explain the principle of the stone columns. Identify the influence factor for stone column. Design stone column techniques. Okay. Okay, so as I mentioned before, we have several types of material used, okay, as the deep replacement methods. Okay. However, in this topic, okay, we more investigate, okay, or more explanations on the stone columns methods only. Okay. So the concept may be similar, okay, whereby we use any other type of material. However, for the calculations or design, okay, we only concentrated on the stone columns or only on stone material, okay, for the designs of the improvement of the weak soil area. Okay. So we may we try to explain, okay, what will be the influence factor, okay, that need to be considered when we design for the stone columns. Okay. So on the design, okay, we may learn on to determine the settlement. Okay. And if I'm not mistaken, also we may learn on the bearing capacity as well. Okay. So I have shared also the calculation, okay, on the design of the stone column. Okay. So, okay, for the stone column, okay, you need to pay full attention on the design related to the settlement. Okay. So don't worry, during your final, you will be provided with the equation. Okay? However, you need to know the procedure, okay, or the step to design, okay, for your stone column, for example. Okay. Okay, so this is the concept of the deep replacements. Okay? How does the deep replacement improve the grounds? Okay? So deep replacement method improve the ground to a great depth. Okay? So usually we will try our best to meet the hard layer, okay, during the installation of the deep replacement methods. Okay. Okay. By partially excavating or defacing chromatic geometry to form a column, the soil had to be removed of this place to give way for the formation of column. So later on, I will show with you how the process of the column installations. Okay? So ideally, the concept of the deep replacement, where we replace, okay, the weak soil with a better or quality material, okay, or we densify the fill or concrete in the column form. Okay, so there are several techniques, okay, that are available. For example, one we replace when we during the installations, okay, we use vibro replacement methods. Okay? So, for example, in this diagram, okay, okay. So we have also a vibro displacement, okay, or vibro concrete column, okay, where they involve vibrations, okay, during the installations. Okay, the idea is to densify the material during the installations, okay? And then to make sure that the weak material, okay, can be easily replaced by this new material. Okay? So there are control modulus stiffness columns, okay, sand compaction columns, okay, and case granular columns, RAM aggregate column, and dynamic replacement methods. Okay? So there are common several methods, okay, used, okay, to treat for the weak area. Okay? So the column and the surrounding soil form a composite ground or foundation to carry vertical loads or a shear force. Okay? I've mentioned before that the term of the composites. Okay? So, so by replacing the weak soil, okay, so with a several stiff material like a column, so can increase the bearing capacity, okay, reduce settlement, increase stability, and also can accelerate the consolidation of a soft foundations. Okay, so that is the idea of using the deep replacement. Okay, so yeah, for example, to accelerate the process of consolidation, okay, once we have installed this material, so then we need to what we call as use preloading methods. Okay? So the preloading methods, okay, will help to accelerate the consolidation process. Okay? So at the same time, what we call as the granular column, okay, we provide a drainage systems, okay, that allow for the water to dissipate, okay, from the weak area. Okay. All right. Okay, so this is the installation process. Okay. So columns with surrounding soil to form a composite ground or foundation can increase bearing capacity, reduce accelerate settlement, increase shear strength for slope stability, and increase resistance to liquefactions. Okay. So most of the deep displacement column can be used to support industrial, residential, retail building, storage tank, embankment, and walls, bridge abutment, railway widening, wind turbine, and utilities, and also for the pipelines. Okay. Okay, so this is the sequence of the installations. Okay. First they do the they uh, what we call as they penetrate into several depths. Okay. So when they start, when it reach the what we call it, when it reach the desired depth, okay, so then um, the augering system, okay, will what we call as we let uh, the granular material, okay, to be filled, okay, at the bottom place first, okay, and then by sequence, okay, until it reach the top or the ground level. Okay. So during the installation, they will use the vibration methods. Okay. So why they use the vibration method? Okay. The use of the vibration method to densify the granular material to, to reach several desired density. Okay. So and then the area of the improvement depends, okay, on how much the vibration is being used, okay, to reach several diameter of the column uh, wide. Okay. So this what we call as these methods usually used to cater for a uh, small uh, small load. For example, a single story building, okay, uh, not for a heavy load structure because they doesn't use, for example, a reinforced bar, okay, to increase the strength uh, of the improvement structure. Okay. Okay. So this is from the slide number 3. Okay. So the excavation method has little effect on the surrounding soil, while the displacement method has more significant effect, also depending on the soil types. Okay. So they have two type of installations. Okay. They call as a excavation method. What would be the disadvantage and advantage for having the excavations or the displacement methods? Hmm? So for the excavation methods, excavation of geomaterial from the ground can be accomplished in two ways. Hmm? So the first one is by injecting a water into the ground, okay, where is the A, okay, turning the geomaterial into slurry. Okay. So means that the existing material will be turned into slurry. Okay. And flushing it out from the hole. Okay. So later on, they will replace, okay, the they call it as a geomaterial or existing material, okay, with any type of uh, strong and stiff material. Okay. So another methods, okay, by using an auger, okay, which is a normal way to bore a hole, okay, inside the what we call inside the wheat soil, okay, and then replace it, okay, uh, with aggregate columns, okay, by using a primer. Okay. Primer like a hammer. Okay. So then each time they pour the granular material. Okay. So then they uh, um, compress it, okay, by using the RAM. So the problem with the excavation, okay, so uh, they need to prevent it from the bore, from the whole collapse. Okay, okay. So another part is by using the displacement. Okay. Uh, the first one, okay, by injecting air into the ground, okay, which is the PNC. Okay. So they use what we call as an air. Okay. So once they have inject the air, okay, at the same time they uh, pour the stone, okay, to replace the hole that is being made by using the air jetting methods. So B and C is a method of using the displacements. And by driving a steel casing into the ground. Okay. So for example, like E and F, okay, they use a special casing. Okay. So this casing also used to prevent from the from the hole to collapse, okay, during the installation process. Okay. So for example, F, okay, they're using a geosynthetic casement. Okay. It mean that the casement has been made by using a geosynthetic. Okay. Then later on they fill the casement, they fill the geosynthetic encasement, okay, with a granular material. Okay. I have a one PhD student. Okay. They use the stone, they carry out study on using a stone column. Then they enhance the stone column, okay, by using the geosynthetic encasement. Okay. Okay. For the encased granular column, when a column are formed by a granular field, their load capacity highly depends on the strength of the field. okay, and the confining stress of the surrounding soil. Okay. In soft soil, granular column may not have sufficient capacity to support loads. Okay. So concrete column or may be used instead. Okay. Alternatively, okay, geosynthetic encasement may be used outside the column to provide lateral confinements and increase their capacity as shown in the figure 5.1F. So that is the idea of using the geosynthetic encasement. Because they want to prevent from the lateral movements, okay, when there is a load applied on the treated uh, area. Okay. So in that sense, by having the geosynthetic encasement, it can prevent from the lateral movements. So it can increase what we call as the capacity, okay, because the concentrations only on the from the vertical. Okay. Okay. So another method for the displacement by driving a reverse flight displacement auger into the ground. Okay. For example, 5.1D. Okay. And by dropping a temper to penetrate into the ground. Okay. So basically, the excavations is to create a hole first, then replace with the granular material. Okay. While for the displacements, okay, uh, during the installations, okay, wait, yes. Okay, give me 3 minutes. Eh? Okay, I have some thing to do urgently. Okay, wait, eh? Okay, sorry. Okay, in terms of suitability, and excavation methods is mostly suitable for cohesive soil. Okay, because if we use it to bore a hole, okay, inside a granular or inside a cohesive soil, okay, so there will be a potential for the hole to collapse, okay. So the cohesive soil, okay, at least it can what we call is it can it has a sticky material, okay, because it has a cohesive uh, cohesions, okay, inside within their soil particle, okay, so it can at least it can reduce the potential to collapse. Okay? While a displacement methods, okay, is more suitable, okay, for both cohesive and cohesiveless soil. Okay. So the excavation method has a little effect on the surrounding soil, while the displacement method has more significant effect on the surrounding soil, depend on the soil type. Okay. So for example, for cohesiveless or unsettled soil, displacement process may densify the surrounding soil. However, for saturated cohesive soil, the displacement process may cause disturbance to the soil, including heaving and lateral movement. Those may not be suitable for sensitive soil. Okay? So in that sense, okay, the excavation methods, okay, is more suitable, okay, to treat for the saturated cohesive soil rather than the use of the displacement methods. Okay, technologies excavation, okay, excavation methods, okay. The technology involving excavation includes vibro replacement by vibro flotation and ramp aggregates columns. Okay, the column installed by vibro replacement, okay, also called the wet method, are commonly referred to a stone column or granular pile. Okay. While for the ramp aggregate column, okay, are installed by removing soil with an auger, okay, then backfilling aggregate followed by tamping. Okay. So during the tamping process, there is some degree of displacement toward the surrounding soil. Okay. So this technologies backfill ground fill from the top of the hole. Therefore, the installation procedure is often referred to a top feeding, and the column installed using this process are called a top feed columns. Okay. So basically, there are two type of uh, installation for this tamping for this RAM aggregate column. Okay. So they are top feed and also another one they call as a bottom feed. Okay. So the one that I share with you is called the top system. Okay. So this is for the excavation methods. Okay. So for the displacement method, okay, they have a vibro casing, okay, vibro probes, okay, reverse flight displacements, and also dynamic placement. Okay. Later on, we try to find um, YouTube, okay, to show the process, okay, for the displacement methods and for the excavation methods. Okay. So another method they call as a dynamic replacements. Okay. So a spatial displacement methods. Okay, granular feed is pushed into the ground by a repeated dropping of a temper to displace soft soil. Okay. So weak soil layer. Okay. Soft and very cohesive soil. It can be also an organic soil. Okay. Organic soil. Okay. So then the layer at the second layer, usually a strong soil, okay, where you have a stiff and uh, very stiff cohesive soil. Okay. So then the process is by uh, make a hole, okay, and then uh, fill the hole with granular material. Okay. Then uh, use a dynamic replacement approach um, by use what we call as a width, okay, a dead width, and then uh, with a certain height to up to 25 meter, so they release the dead width. So this is a method, okay, by using a dynamic replacement. So granular feed is pushed into the ground by repeated dropping of a temper to displace soft soil. Okay. So the vibro casing method send compaction columns. Okay. So steel casing driven into ground with a vibrator to displace the soil. Then backfill with granular fill. Okay, then densify the fill. Okay, so the vibro casing method commonly referred as the sand compaction column or pie method. Okay, they drive a steel casing into the ground, okay, by using a vibrator, okay, to displace the soil. So then they backfill the granular fill, okay, mainly sand but sometimes aggregate through the casing, then densify the fill by repeated extraction, the penetration process. Okay. So that is the use of the vibro casing. Okay, difference between vibro probes, okay, where the probes are used, okay, that have vibrations, okay, during the installations. Okay, used with pressurized air to displace the soil. Okay. So when they have displaced the soil, they introduce the granular field through a center tube of a side tube, densify the field by vibration of the probe. Instead of granular field, a mixture of cement, fly ash, and gravel or low strength concrete is sometimes used. Okay, the column formed by the cement, fly ash, gravel mixture are often called as a CFG. Okay, while those formed by concrete are also called vibro concrete columns. Okay, so it means that the system, okay, have a special nozzle that can inject or allow for the concrete, okay, to fill the the hole, okay, uh, and mix with the existing material. Okay, so the vibro probe techniques, also called the dry method, can be used with pressurized air to displace the soil, introduce the granular field through a central tube or a side tube, and then densify the field by vibration of the probe. Okay. So that is the method of the use of the vibro probe. Okay. So the one that we have discussed before, that we have a top feed. Okay. So this vibro probe, okay, they call as a bottom feeding. Okay. So means that they uh, they fill the bottom hole, okay, with the granular material or with the any type of stabilizer. Okay, so the top fit, okay, uh, they make a hole, then they pour from the top. Okay, so the bottom fit, okay, sorry, okay, they mix, okay, they they make a hole, okay. So during when the hole reach the bottom or the desired depth, so then they fill the bottom first, okay, until it been filled up to the top. Okay, so that is the uh, bottom feed, okay, bottom feeding system, okay. So reverse flight displacement, okay, the reverse flight displacement method displace soil by a specially made auger, then the then replace the displaced soil by grouting. The grout can be designed and prepared at different strength and modulus based on the needs for the project. Therefore, this type of column are referred to a control modulus stiffness column or auger displacement columns. So in this method, they do not use what we call as a granular material. Okay? So they replace the what we call as the area with uh, concrete. Okay, so it is actually similar like what we call as a bore pile. Okay, because some of the cases they use a reinforced cage. Okay? Then they pour the concrete. Okay, so there is another type for the deep replacements. Okay. Okay, so this is the suitability of the methods. Okay. Um, for each type of the deep replacement methods. Okay. So, for example, the use of the vibro replacement. Okay. So, it's suitable uh, for the cohesive soil with the undrained shear strength higher than 15 kPa. Okay, with a depth of up to 15 meter. Okay, so then we have a vibro displacement. Okay, so the vibro replacement, we make a hole, then fill it with any granular material. Okay, so for vibro displacement, okay, during the process of the augering. So at the same time, they inject or they include the granular material inside it. Okay. So suitable for insensitive cortisol with undrained shear strength from 15 to 60 kPa. So can be up to 15 meter deep. Okay. So control modular stiffness column. Okay. So this is like a ball pile. Okay. So it's suitable to treat for the loose sand, uncontrolled field, softly and seal and organic soil include pits. It can be up to 20 meter. So then we have a sand compaction column, okay, suitable for caustic and cohesive soil. Okay, it can be up to 70 meter deep. Okay. So encased granular column with the use of the geosynthetic, okay, as a encased system. It's suitable for very soft soil and organic soil with undrained shear strength as low as 5 kPa. So it can be up to 10 meter deep. So the RAM aggregate column suitable for soft to stiff clay, loose silt and sand to dense sand and uncontrolled field, okay, and suitable up to 10 meter deep. Okay, the last one is the dynamic replacement. Okay, suitable for the saturated cohesive soil and soft organic soil. Okay, so you can treat up to 8 meter deep. Okay, so this is the guideline. Okay, uh, based on the grain size of the material at the field. Okay, so if we are dealing with fine material, okay, so then the best method is the use of the vibro replacement methods. Okay. So if we deal with coarse material, okay, so then the use of the vibro compaction methods is more practical. Okay, now we look on the advantages, okay, of the several deep replacement methods. Okay, so in this case, I divided into three common material. Okay, the first one is the sand column. Second one is the stone column, and the last one is the RAM aggregates. Okay. So then after that, we look on the limitations of each the same material, the same method. Okay. So for the sand column, okay, use of a lower cost material. Okay. So it is a fast construction. Okay. So fully supported home. Okay. Limited intrusion by surrounding soil. Okay. So then we have a stone column. Okay. Long track record of successful applications. Installation is fast and easy. So high strength and stiffness. So does not generate spoil. Okay. Then for the RAM aggregates, okay, rapid installations, high level of compaction, easy for quality assurance and quality control procedure, can distress surrounding soil, can provide uplift with pre-installed bar. So that is the advantages of the uh, sand column, stone column, and ramp aggregates. Okay, this is the limitation for the same type of methods. Okay, so lower friction angle, casing penetration and extraction induce smear to surrounding soil. Smear is during the installation. Okay, so there will be a potential of disturbance happens. So this disturbance can consider as smear. Okay? So it can reduce the strength nearby the surrounding pole during the installations of the sand column. So it depends on the type of the sand. Okay? If the sand is very fine, so it can contribute to the insufficient permeability. So for the stone column, the issue of the use of the top feeding generates spawn, which is not environmentally friendly. Okay? So to overcome the issue of the top feeding, so that is why they introduce the the bottom feeding system. Okay. So then for the RAM aggregate, limited improvement depth, difficult to be installed in clean sand with a high groundwater table. Hmm. Okay. So this is for vibro compaction. Okay. The compaction of the soil using a vibro float in horizontal motion from the vibrator inserts into the ground. Okay. So then we have another, they call it as a vibro replacement, a technique of constructing dense aggregate column, stone column, to fill material and weak soil with a down vibrator suspended from a crane or specially built rig. Okay. So improvement of the weak ground to a great depth can be done by partially excavating or displacing problematic soil and in turn replacing the poor soil with a better quality or densified field or concrete in columns. Okay. The success of in situ depends on the grain size distribution in situ soil and backfill soil. The construction of the dense aggregate column with a downhole vibratory suspended from a crane or specially rigged. Vibro compaction rely on the densified in situ soil, while deep replacement rely on using column together with the surrounding soil to form a composite foundations. Okay. So the vibro compaction, okay, it rely on how they densify the existing uh, soil. Okay. So while for the deep replacement, they rely on the using of the columns. Okay. So means that the vibro compaction, okay, they will compact the existing soil, okay, and then improve it by using the by adding any granular material, okay, during the compaction process. Okay, so for the vibro replacement, okay, they replace the existing soil with a better uh, granular material that form in a column. Okay. So this is for the stone column. Okay. As I mentioned, there are two types of uh, installation method. Hmm. They call as a top fit and bottom fit. Hmm. So the stone column and the intervening soil form an integrated foundation system, a support system, having a low compressibility and improved load bearing capacity. Hmm. So in cohesive soil, excess pore water pressure is readily dissipated by a stone column, and for this reason, reduced settlement occur at a faster rate than is normally the case with cohesive soil. So it means that uh, after we have removed the cohesive soil with the granular material, okay, so it can help to accelerate the consolidation process by providing a drainage system, okay, where allow for the water to dissipate, okay, from the granular column system. Okay. So as a result, okay, it can accelerate the consolidation rate, okay, and it can reduce the settlements. Okay. Improve their load bearing and settlement characteristic. Okay. Unlike clean granular soil, fine granular soil such as soda does not densify effectively under vibration. So that's why they use the stone columns. Okay. So once we vibrate the column, okay, it can densify, okay, better compared of the use of the fine granular soil. Hence, it is necessary to form stone column to reinforce and improve this material with cohesive and mixed soil. Okay. So this is during the what happened, okay, during the installations. Okay. So then after we impose loads on the system, okay, so there will be a budging effect. Okay. So to overcome the issue of the budging, so that is why they use the encased geosynthetic, okay, prevent from the lateral movements. Okay. Okay, basically the stone column is so so basically for the stone column, we may allow to have what we call as a budging effect, okay, because that is how the system will deform, okay, after it's been loaded with a load, okay. So that is for the stone columns. Okay, now I will try to find, okay, from the YouTube, okay, in terms of the installations, okay, for the deep replacement methods. Okay. Okay. So this is for the deep bottom feeding methods. So this is vibro replacement methods. Okay, so this is a bottom feed system. So means that the stone column, sorry, the material will be insert from the bottom and then they vibrates, okay, mm, to densify the the granular material. Okay, so that is that called as a vibro replacement methods. Okay, let me find another example. Okay, this is vibro compaction method. Okay, so this is called top feed methods. Okay, so means that uh, they pour the granular material from the top. Hmm? So then they compact it. So they pour the hole, then they fill the hole with the granular material, then compact it at the same time. Then they complete the process. Well, phrase for checking. Okay. Okay. So then we look for any type of okay. Hydro. This is too long. Okay, we try to find any other type of hydro. Right aggregate. How to find the right aggregate? Stone column. Okay, that is the process. So this is also a bottom tip method. So they tempered the granular material. That's why they call it as a RAM aggregate method. Right. So try to find hydro very small. Bottom tip. Mm, this one. Okay, so that is for the vibro. I try to find for the vibro displacement. Vibro displacement. Also, try to do on this one. This is bau, eh? Okay, so that is for the vibro displacement. Okay, the difference only on the type of the methods, on type of installation method. Okay, we look on the deep missing method, or the dynamic compression method. Basically not this one. Or the solution method. Deep missing. So this is deep missing method. So they mix what we call as the soil with the existing with the stabilizer. Okay, so that is for the deep solvency methods. Okay. Total. Okay, the last one. Okay, can we take a photo? Then we take a rest for 15 minutes. Okay.